Before we move on, we're going to look at some more word problems from 10.2, and that was graphing quadratics. So the first thing I want you to realize is that you need to visualize what the question is asking. So the first thing I would like for you to do is to visualize if something asks you how far something went or what time it took. So I want you to kind of look at this first problem down here. It says a pine cone falls about 49 feet from a branch of a pine tree. How long does it take to land on the ground? So notice you're dealing with 49 feet and it's asking how long it's going to take. So that's going to be a time. So I want you to visualize, okay, if I have an X and a Y, and X is time, in this case would be seconds, and this is feet from where the pine tree is going to be, how tall it is from the ground. The pine cone was 49 feet. So I need you to realize what units your X and Y axis will be. So if this right here is 49 feet and the pine cone falls, time keeps on ticking. So this would be the shape of your parabola. Now keep in mind that this right here is going to give you the time. So this is going to be how long it takes. So in this situation, you are in fact looking for time. Now, most of these problems will use our vertical motion model. And you really need to memorize that, but more importantly, you need to know how to use it. So remember, it is h equals negative 16t squared plus vt plus s. Now, think about if the pine tree is dropping the pine cone, that would mean your velocity is 0. So in this problem, we're going to have h equals negative 16t squared. We're not going to have a velocity, and it starts out at 49. Now, yesterday we talked a lot about the min and the max. Notice this problem is not asking us how high the pine cone is. They gave us that. It's asking how long it takes. So how would you end up solving this? Well, you would actually solve this with factoring, okay? Or you could actually get t by itself. But at this point, I would expect you to be able to recognize, oh, I have difference of squares. And if you rewrite the problem, you will be able to see difference of squares better. So then you could factor this, 7 and 7, 4t and 4t, plus minus. And then if you go to solve this one will produce a negative 7 over 4, but this one over here will actually give us a positive 7 over 4. So t equals 7 over 4. But what does that really mean? That means the pine cone will hit in 1.75 seconds. So that problem did not ask us to do min or max. So you have to visualize what is going on. And keep in mind, the pine cone falls to the ground. So it probably does go straight down. This is modeling the time the pine cone takes, because it starts out slow, but as it reaches the ground, it'll get faster and faster. Now, if you'll look at the next problem, number 2, it says the cables between the towers of the Tucahoma Narrows Bridge form a parabola that can be modeled by the graph of the equation. And we have this really long equation. X and Y are measured in feet, and the height, and it wants us to find the height of the cable above the water. Now we had one like this in our notes yesterday, but what I want you to notice is that it says X and Y are both measured in feet. So once again, let's visualize. So let's draw our X and Y axis. And notice it said they're both feet in feet. So it's not asking us the time of the bridge because that doesn't make any sense. It's asking us how low it's going to be. Well, notice how it's got a 0.00014. That tells me that it's a stretch, and that also tells me that it's a parabola opening up because A is positive. So we don't have to be, like super accurate. We can envision a suspension bridge. It's going to look something like that. And it's asking how low, okay? So once again, you have to know Am I finding x or am I finding the vertex? And in this case right here, this is saying how low. So we are going to find the minimum on the graph, and we know that is the vertex. And remember, the vertex is a point, and we really care about y because that's going to tell us how low. X tells us how far over. So let's go ahead and work out number 2. Okay, we'll kind of go right here. And once again, to find our vertex, we need to do the negative b over 2a. And that's going to be negative 0.4, so that'll turn to a positive, over 2 times a. So this is going to require the calculator. And remember, when you're typing this in on the calculator, use parentheses on the bottom. So I have 0.4 divided by parentheses 2 times 0.00014, and I get 1428.6. We're going to round it. Now, remember, I also taught you yesterday that you can store that number. If you hit store x, your calculator will now use that as the x. So I can simply type in my equation, 0.00014. I can do x squared minus 0.4x plus 507. And then I get 221.3. Now, if that is x, that means this is y. So to answer this question down here, what is the height of the cable above the water at its lowest point? That is going to be 221, and we can round it approximately 221, and that's going to be in feet. So keep in mind, this bigger number means the bridge is really stretched out, but then the 221 would be right there. It's how low it is. Now, what I would like for you to do is to go ahead and do 3, 4, and 5 and pay attention to what it's asking you. Is it asking you how high something is, how low something is, or how long it takes to land, or even where it lands?